Good morning students, this is Rahul sir and you are most welcome in Mind of classes. In previous class we had studied the different types of functions and today we are going to continue that topic, and the fourth type of function is rational function. The fourth is rational function. So what is a rational function? Any function which is given in the form of p by q. Okay, and rational function will be that should be in p by q form. Okay, and it should be like two algebraic functions. Okay, like hx is equal to fx upon gx. Okay, that means hx is equal to, like, let us say x square plus 1 upon x minus 1. Okay, so this is our fx and this is our gx. Okay, so this hx is a function and this is in the form of rational form. Okay, this is a rational form. Now listen, graphs of different types of functions are given in your book and you can see there also. Now let's talk about a modulus function. Okay, modulus function. What is a modulus function? And please understand this modulus function because this is very important one, and why I am paying more attention in this set, that is function, is because this function will appear in your further classes, that like is in maybe in this class also and in 12th also. Okay, so but if you are not capable to understand this function right now, then that if you see that in class 12, that will be very much difficult for you to understand what does it mean and you will not be able to comprehend that. So let's understand what is a modulus function. Let us say a function fx is given mod of x. Modulus function means mod of x, any function which is written in the form of mod. Okay, mod form. Okay, so this is modulus function. Okay, so fx is given in the form of mod of x. It can be also gx is equal to x square plus 1 or something like that, or minus 1, something, anything like that. Okay, so the function which is written in the form of mods. Okay, so this type of function is known as modulus function. Okay, now what is the speciality of this function? We must understand this thing. Okay, what is the speciality of this type of function? Let us say here we are having fx is equal to mod x. Okay, so this we know that x mod of x, or any number, if we take mod of any number, that number will be equal to always positive number, whatever it is. Okay, let us say if we take mod of minus 7, it will be equal to 7. If we take mod of 7 only, then it will also be 7. Okay, that means mod always gives you a positive number. Okay, always a positive number. Now, so how this is possible? How this is possible? Then the main question arises here, that what does mod signifies? The mod signifies that fx is equal to x when x is greater than 0. Sorry, x is greater than 0, and minus x when x is less than 0. Please understand it. Fx is equal to x when x is greater than 0. That means if the value of x is greater than 0, then fx will be equal to x. Now, if the value of x is negative, minus 1, 2, 3, minus 7.5, whatever it is, we get a negative sign with x, then the value of function will be equal to minus x. At that case, if x equal to minus 4, then f minus 4 will be equal to minus x, or we can say here fx equal to minus x. So f minus 4 is equal to minus 4, and that will get plus 4. Okay, and this is how modulus function always gives you a positive number. Okay, this is how we do this. Okay, this also applies each type of modulus function. Okay, so this is a modulus function. The diagram for mod x is given to us like this. Okay, so for now this graph is not that much important, so I am not going to explain that much. Now next topic is signum function. What is a signum function? Signum function is a special type of function in which if x is greater than 0, the value of function is 1. Okay, if the x is less than 0, then it is minus 1, and if x is equal to 0, then fx is equal to also 0. That means if x is greater than 0, the function value will be equal to 1. If x is equal to 0, then the function value will be 0. And if the function value is value is less than 0, then the function value will be minus 1. Except these values, there will be no other values of this function. So such type of function is known as signum function. Okay. And the diagram for this is okay. This is our diagram for signum function. Okay. Now next is greatest integer function. Please understand this one. If you are not able to understand this type of question, you will find very difficulties in further classes and in this class also. What is a greatest integer function? Please understand here. Greatest integer function. Listen. Here x belongs to R. Listen. Fx is such that x is greatest integer function is represented with capital brackets. Okay, big brackets. We represent the greatest integer function with the help of these big brackets. Okay, so what does this represent? Here I have written one more thing, that x belongs to R. That means x should be a real number. Okay, x should be a real number. If x is a real number, then what will be the value of x? Okay, now if the value of x can be a real number, so it can be possible that the value of x is 1, 2, 3, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.9. Okay, like this. The number can also be equal to 3.33, 3.35, 3.37, 3.37578. Like this numbers can be also be possible. Okay, so the real number, what will be the real number of this function? Let x equal to 3.3. If x equal to 3.3, then that means fx is equal to greatest integer. Greatest integer means the number less than this and which is a integer. The number should be less than this and the integer. Okay, just below the integer of this number. So what is the number which is just below this number is when x equal to 3.3, the value of the function will be equal to 3. If x value is 3.35, again the value of the function will be again only 3. Why? This is not an integer, this is also not an integer. Okay, if this is not an integer, so we will take the lower number just below that 3.35. Okay, similarly, if x is equal to 3.9999 and up to infinity, then fx will be equal to 3.9999 dot dot dot, and the value will be equal to 3. But just pay the attention in the next point. As soon as we put the value of x equal to 4, if x is equal to 4, then fx will be equal to 4. Because 4 is already an integer, and if it is already an integer, so the value of function will be equal to 4. In the next point, if x is equal to 4.1, again fx will be equal to only 4. That means the value of fx will be 4 until it exactly equals to 5. Okay, as soon as we reach 5, the value will become 5, and if we go further from 5 before 6, then the value of function will be equal to only 5. Likewise, this is called the greatest integer function. Okay, now if you want to understand the graph of this function, please understand the graph of this function. What I told you, if we put x equal to 3.3, okay, then what we will get? Fx equal to 3 only. Okay, now 1 2 3 4 5 1 2 3 4. This is fx and this is x. Okay, now what is the value of x is 3.3. So 1 2 3 4, here is 3.3. the value of fx is equal to 3. This again 3.5, the value of x is 3 again. Now if we put the value of x equal to 3.999 and all, then still this number value will be equal to 3 only, and this number will start from here. Okay, so this, and as soon as we reach 2.4, the value will become 4 again, and this will continue up to 5. Okay, as soon as we reach 5, the value will become 5 and so on. So this is how we make the diagram. This is how the diagram of this function will become. Okay, so this is the greatest integer function. Now let's talk about algebra of real functions. Algebra of real functions, you have already studied the algebra of adding the n into polynomials, adding, subtracting, division, multiplication. You already know these things, and the same thing will apply to these questions. And so we will complete this exercise 2.3, and from here our chapter number 2 is completed. Thank you.